Okay, so I don't have the lab question at home with me, so I decided to make a podcast on the 1970 question because it involves a similar, the only tricky part I saw in the lab I also saw in this question. So the first 1970 question asks you, what's the pH? So this is just a simple ice problem. We ice it out and we find the pH is 2.2. Then in B it says, what happens if we make a buffer by adding hydroxide? So remember, there's two ways to make a buffer. One is weak acid and its conjugate salt. The other is weak acid with a strong base. Okay, and the same, we can flip it around if we wanted to make a basic buffer. It would be a weak base with a strong acid or a weak base with its conjugate salt. So we add the hydroxide and you can see it makes a buffer because we have the weak acid and suddenly we also have its conjugate base, okay, because the OH moles added to the other side. I also saw in this problem right away that the moles of the acid and base were equal, so I knew that it was halfway to the equivalence point. If you recognize this, it saves you some time because you know at halfway to the equivalence point pH equals pKa. If you didn't, you're still fine because you can just ice it out and you'll end up seeing when you get down here that you can cancel in the Ka expression, you can cancel those two values and Ka actually equals the H+. Okay. Then in C it said, what if we take 40 milliliters of the buffer solution? So that is also what happened in the lab. We had 100 milliliters of buffer and they said, what if you add some base to the buffer but you add it to 40 milliliters of the buffer? So I took my buffer and they were actually adding acid. So I knew that the acid had to react with the base part of the buffer. So I knew to write the equation this way because the acid had to react with the base part. Then I had to figure out what is my before. So I took 0.5 molar, which I knew from up here, 0.1 divided by 0.2. Is that 0.5? Let me check it. Hang on. Yes, so I knew my molarity from right here, and then I multiplied it by the 40 milliliters to find the moles. Okay, so that was kind of, you had to make sure you thought about that to catch it. So then I only had 0.02 moles, and I have 0.05 moles of H+ because of however much they told me to add. And so you do the change and the after, and we find that we have H+. And I wrote on the key here, we already have H+ from a strong, so we don't need to figure out how much H+ is also coming from the weak, because remember, when you have a mixture of strong and weak, you can ignore the weak and just go with the strong. So I ended up taking the moles and dividing by the total volume to find my new molarity of the H+. If you wanted to do this for the lab problem, you would find that buffer C started with 4.74 as the initial pH, and then you would need to do a Becca and then ice for the milliliters that they added, and you would find that the final pH after you add the hydroxide is 4.85, so a change of only 0.11. And you would need to take buffer B and take 40 milliliters of it, just like we did here for the moles, and add the hydroxide, and you would find that buffer B started at 4 pH and changed to 4.28, so there was a greater change in buffer B than in C. So the more moles, the more it can resist a change in that pH. Okay, thanks.